Hello, and welcome to Backer Breaks It Down. In today's episode, we're going to take a look at the sine and cosine functions. Now, I know we have previously worked with sine, cosine, and tangent when we were solving right triangles. Okay, so now what we're going to do is we're going to take a look at sine and cosine and their connection to the coordinates of a point on the unit circle. Okay, all right. So we got the unit circle. So a unit circle is a circle that has a radius of 1 unit. Okay, and so notice I've got the unit circle here, and the radius we're talking, it goes from the center to a point on the circle. That's a radius. Okay, and so as you go around the circle, the radius stays constant at 1 unit. Okay, the angle theta is determining a point on the circle given by x, y, right? So check it out. Okay, so if theta is an angle in standard position whose terminal sides intersects a unit circle, then we can say that the xy ordered pair, x is equal to cosine theta, y is equal to sine theta, which means in terms of trigonometry, the ordered pair xy can be written as cosine theta, sine theta. Okay. So there are some angle measures already on the unit circle, as you can see. So 0 degrees. So notice at 0 degrees, we have the point 1, 0. That is not supposed to be a highlighter. Okay, and it still is. That 1, the x coordinate of 1, well, that's cosine of 0 degrees. So that's saying that cosine of 0 degrees is equal to 1, sine of 0 degrees is equal to 0. The 90-degree mark, we have the point 0, 1. So what that is saying is that cosine of 90 degrees is equal to 0, and that sine of 90 degrees is equal to 1. Okay, now not all circles are unit circles. I mean, the unit circle has a radius of 1 unit. All right, so how do we find exact values of sine and cosine when the radius doesn't equal 1? Okay, well, that's simple. We're simply going to have to divide by the radius. I mean, if you think about it, if you were to take cosine theta here, okay, so so this is saying x equals cosine theta, and this is true when the radius is 1. Okay, so basically think oh, I'm dividing x by the radius. The radius is just 1 though, so of course x is equal to cosine theta. Well, the radius is something else. I'm going to have to divide x by that radius. So this is saying x over r is equal to cosine theta, y over r is equal to sine theta. Okay, now this is nothing new. So as I mentioned at the very beginning, we have studied sine and cosine, okay? And we know sine to be the ratio of the opposite over the hypotenuse, okay? So look at this triangle here. If I wanted to find sine, wouldn't I use the ratio y over r? Because isn't y opposite the angle? And isn't r the hypotenuse? Yeah. So it's not anything different from what we were working with before. It's just before, we would usually be given a right triangle with 2 or 3 sides on it, and we could easily just look at the right triangle and be like, oh, sine is the opposite over the hypotenuse, and it's these 2 numbers. Okay, but here we're on the unit circle, so we're going to have to find r. Okay, because if you're given the coordinates of a point on the unit circle, that means you know x, you know y, but you don't know what r is. Well, something else that you already know, you've worked with in this course and in many courses prior, is the Pythagorean Theorem. So we can use the Pythagorean Theorem to find the radius of our unit circle. So going back to that triangle here, where I'd say that x squared plus y squared is r squared, and then if I take the square root of both sides, I get that r, the radius, is equal to the square root of x squared plus y squared. Okay, so really, it's just like the information's being given to us differently. So instead of like giving us a triangle with 2 or 3 of its sides, we're being given like the coordinates of a point on the unit circle. Okay, and we can use those coordinates and we can still find the values of sine and cosine, and we can still use, those SOHCAHTOA rules. So sine is the opposite over the hypotenuse, cosine is still the adjacent over the hypotenuse. We're just representing them with different variables here, okay? So when you're given a point on the unit circle, you need to draw a reference triangle. You're going to draw so many reference triangles. But basically, it's a right triangle. The vertex is at the origin on the coordinate plane, and we want to make sure it's in the proper quadrant. Okay. We're going to label our sides accordingly. Watch your signs. And then we're going to use the Pythagorean theorem to find the value of r. Now, the value of r, no matter what, will always be positive. Okay. It's always going to be positive. So we don't have to think about the sign when it comes to r, because it's always going to be positive, no matter what. So let's actually take a look at an example. So here in number 1, I want to find sine and cosine. All right, so I'm still going to use the fact that, sine is the opposite over the hypotenuse and cosine is the adjacent over the hypotenuse. Like, I can still use those, okay? It's just look at what you're given. You're given the coordinates, the terminal side on the unit circle, well, on a circle. All right, so we first have to think, like, where is this point located? And so because both x and y are negative, because it's -4 and -2√5, that would be quadrant 3, because in quadrant 3, both x and y are negative. So I'm going to draw quadrant 3. Okay, I'm going to draw my reference triangle. Okay, my reference triangle is like, think of it being as part of a bow tie when you're drawing it. Okay, and then I'm going to label the sides accordingly. So what I know here is that the x side is -4 and the y side is -2√5. So the x side is -4, the y side is -2√5. So I need to use the Pythagorean theorem to find the radius, the r value of my triangle. So I already went ahead and I did this. Okay. So that r squared is equal to -4 squared plus -2√5 squared. That was 36. Therefore, r is 6. Okay. So now I've got all 3 sides of my reference triangle, and now I can find sine and cosine. So I can still use my old prior rule that sine is the opposite over the hypotenuse. So here that'd be -2√5 over 6. And then I can simplify this. So -2 and 6, they're both outsiders. So I can totally simplify that fraction. And that would give me like -1/3. So I'm looking at like -1√5 over 3 for the exact value of sine. When it comes to cosine, cosine has always been the adjacent over the hypotenuse. So the adjacent is -4 and the hypotenuse is 6. And I should simplify that and I get -2 over 3. Okay, so we're still just finding trig ratios using our ratio rules of the past. Okay, we're just given something different than we were in the previous unit, right? So in this problem here, we are given that cosine of theta is 5/11 and it's in quadrant 4. So I'm going to draw quadrant 4, draw my reference triangle. Okay, cosine, like I know, is the adjacent over the hypotenuse. So that's how I'm going to label my sides here. So the adjacent is 5, the hypotenuse is 11. So I need to figure out the y value. And how am I going to do that? That's right, Pythagorean theorem. So I've gone and I've done that. So I'm like 5 squared plus y squared is 11 squared, y squared is 96, and then y is the square root of 96, which is 4√6. Okay, now notice when I labeled my diagram, I have y is -4√6. Okay, because you want to be very careful when it comes to the signs, S-I-G and S, okay? In quadrant 4, y values are negative. So every single time you create a reference triangle, and you got all three sides, I want you to pause and check your signs, S-I-G and S, okay? And then you can find your ratios, okay? So sine, as we all know, is opposite over hypotenuse. So opposite is negative 4 root 6, and the hypotenuse is 11. And so that's how we can find exact values of sine and cosine on a circle of radius not equal to 1. Okay, simply using our rules from the past, just kind of written a little bit differently. And that's how Becker breaks it down.